for the outdoor. So H1 and H2 is given 10 and 25. Okay. So the direction of flows. So you have a 70-meter height and 5-meter wide wall consists of long centimeters, 16 centimeter and 22 centimeter cross-sectional horizontal bricks, separated by 20 centimeter thick plaster layers. There are also 2 centimeter thick plaster layers on each side of the brick and a 3 centimeter thick rigid foam on the inner side of the wall. Okay, K is given for all the materials. The indoor and the outdoor temperatures are 20 centimeter and -10 degrees C. So this one become the inner side because it is stated here that the inner side have foam. Okay, so this is inner, the inner side, okay, with the foam. So the temperature of the inner is 20 degrees C and -10 degrees C for the outdoor. So H1 and H2 is given 10 and 25. Okay. So the direction of flows. So it's actually from left to right. Okay. So next, what we're gonna do, we're gonna divide this into this one. Okay. So we just follow this thermal resistance circuit. Okay. So you're gonna have your 3, 4, and 5. So it means this one is 3, and this is 4, and this is 5. Okay. So it means this is 2, and this one is 1. This is I, inner, and this is 6. So the material for 3, 2, 5, and 6 is plaster. 4 is brick. 1 is foam. Okay, next we need to give the temperatures. So this is T1. T2. This one is T3. Okay. So this is T6. This is T5. Okay. Up to you actually. The thing is, do not get confused later. Okay. That's the most important thing. So where is T1? So this is inner. So meaning T1 is this. And this is T2. T5. T6. Okay, so this is T infinity 1 and this one is T infinity 2. Okay, so next we can assume one-dimensional heat transfer. In fact, we always assume that. Okay, and disregard any radiation. Determine the rate of heat transfer through the wall. Okay, so we need to calculate Q. So Q equals to the temperatures given is T infinity 1 and T infinity 2. So it means okay, so everything divided by R total. Okay, any question? Next is we need to determine the resistance for each of these thermal resistance network. Okay, so we're gonna start with R inner. So R inner is actually 1 over H inner multiplied with the area. Okay, before that, let's calculate the area in terms of per unit width. Okay, so basically, because the width is gonna be 5 meter wide. Okay, but the thing is, when you calculate in per units width, okay, the height is there. Okay, this is the height, 22 centimeter plus 1.5 centimeter plus 1.5 centimeter. So it means the height become 25 centimeter. Okay, so we calculate per unit width because of cross-sectionally it does not change. Okay, it's gonna be foam, plaster and brick, the same for the whole width. Okay, so you can calculate per unit width. So let's say if the width is 5 meter, you just multiply with 5 later on. Okay, so imagine if the same wall is to the other side, for example, is 10 meter wide. Now it's 10 meter wide, but the materials is the same. So the same approach, you just need to multiply with 10. Okay, so for this case, we calculate per unit width. So this one equals to 1 over, so H inner is H1, H1. So multiply with 10. And the area is 25 centimeters, so it means 0.25. Multiply with 1 meter width. So in the end, what you're gonna get is 0.4. Okay, that is R inner. Okay, next we go to R outer. Both are convection. 1 divided by, so in this case is R outer is 25. So the height is still the same. So here you're gonna get 0.16. So we've done with the convection. Okay, next we go to each one of the conductions. So we're going to start with R1. So R1, L over KA, right? So L 1 over K1 E. So the length for foam, okay, because this is one is foam, the length is 3 centimeter. So it means 0.03. And K1, the foam is 0.026. Okay, the area is still the same. Okay, the foam height is 25 centimeter. And this one you're gonna get 4.62. Okay, next R2. R2 is made of plaster, and R2 thickness is the same, so R6 also the same thickness. So basically R2 and R6, when we calculate R2, meaning we calculate R6 as well. Okay, so let's calculate in terms of 2. Okay, thickness is 2 centimeter, so it means 0.02 meter. So now let's take a look at K for plaster 0.22. And the area same, 0.25. This one you're gonna get 0.36. Okay, next we calculate the cluster for R3 and R5. So this one 3 and this is 5. So let's calculate in terms of 3. Okay, the thickness is 16 centimeter, so you're gonna have 0.16 meter. So cluster is 0.22. Okay, now the height is not the same, 1.5 centimeters, so become 0.015. So this one you're gonna get 48.48. Let's see. Okay. So the one left is R4. R4 is made from brick. So L4 16 centimeter, right? So 0.16. Now take a look at the K for brick. It's 0.72. Okay, take a look at the height. Height is 22 centimeter. So it means 0.22 multiplied per unit width. So here you're gonna get 1.01. Okay, done. So any question? Any question?
No, sir.
Okay, now we want to calculate this R3, R4, and R5. Okay, so basically R3, 4, 5. So we're gonna apply the concept of parallel in vertical circuit. Okay, so when it is parallel, so how you're going to calculate this one is 1 over R3 plus 1 over R4 and then plus 1 over R5. So 3, 5 and 4, you're going to substitute all this value and you will get R345, okay, to represent the parallel circuit resistance. So the value is 0.97. Okay, you are familiar with this, right? So next, we determine the R total. So it means R total is R inner, R1 plus R2 plus R345 plus R6 and plus R outer. So sum all the values. This one, our total become 6.87. Okay, so that's it. Now you can calculate the Q. So you have T infinity 1 is 20 degrees C. Minus negative 10. Okay, so everything divided by 6.87. Okay. So from here, 4.37. Okay, so you're gonna get 4.37 watt. Okay, now in order for you to calculate the whole, let's divide this into 0.25 again, which is the height. So you're gonna get Q over A. Okay. Q over the area. So 4.27 divided by 0.25 become 17.47. 17.47 watt per meter square. Okay, so now you get 17.47 watt per meter squared. So in order for you to determine the watt Q, so 17.47 multiplied with the area. So now what is the area? (17 meter high and 5 meter wide. So it's the same. So yeah, betul tu. Okay. So 17.47, you need to multiply with 17, which is the height, and the width is 5 meter. So in the end, what you get is 1,000. You get 1,484.95. What? Okay, so this is the answer. Okay.